Hi, I am going to solve here the problem of chapter 13, and this is sample number 12. So here we have a rod, right? And then we have a coil. A coil is allowed to move freely to that rod, and is attached to B here by a spring. The spring has a constant of 3 newtons over meter, and the coil weighs 2 kilograms. Well, that's the mass, remember, that's the mass, so the mass of the, so we can get the weight having the mass. And we have some distance, and then they are asking us to find the acceleration of that coil and the normal force between the coils and the rod when, actually here, when y is equals to 1 meter. So here we can say that this is 1 meter. So how do we attack the problem? First, we should understand the geometry and then do the free body diagrams, right? So as you see, we will have this force of the spring. So what I will do first of all is to understand this angle right here. To understand this angle, I will find the hypotenuse of this length right here, right? So what we can see, since we have 1 meter here and 175 here, I can say that the hypotenuse is square root of 1 square plus 0.75 is 125. So we could, by the inverse tangents, find that angle, or since we are going to need only the sine and cosine, I can actually define the sine of theta as the opposite over the hypotenuse, right? That's the definition. Or cosine of theta as the adjacent over the hypotenuse. So those are the values that I will need. So now I'm going to do my free body diagram of the coil in position, in the final position. Let's call this position C, at C, which is when y is equals to 1. So what do I have? I have my coil. The forces that are here are my weight, which we know is mass times gravity. We have the normal force. We do not know in which direction this normal force is because we don't know if this coil will touch this wall or that wall. So, but we do know that it's perpendicular to that surface. And then we have the force of the spring. As we know, the force of the spring is K times delta S. Being delta S, the extension of that spring. The problem tells us that the spring is unstretched, at A. So we do know that the unstretched length is this one right here. This is 0.75 meters. Therefore, we do know that our constant is 3, and this will be equals to the stretched length minus the unstretched length. So we know that this is 125, but we just calculated, right? Minus 0.75. So we have the free body diagram, and we have to have our kinetic diagram. And the kinetic diagram is actually very simple because we just have one acceleration. Therefore, my kinetic forces are just mass times this tangent acceleration. Now that I have my free body diagram, you remember that the free body diagram is equals to the kinetic diagram because we have forces equals mass times acceleration, right? So, and this is a vector equation. This is what is called equations of motion. So, applying our equation of motion, we have that the forces in X will be equals to that normal force where we are asked to find plus forces of the spring in the components. So if we know this angle is theta, this angle is theta as well. So therefore this angle is theta as well. So that will be cosine of theta, and this is equals to 0. So normal force is equals to spring force cosine of theta. And from the forces in y, or in the tangent direction, right, we have the spring force, now sine of theta, minus the weight, equals, in this case, minus mass and the acceleration. Let's call this equation 1, and from this equation 2. And you see, here we know the angle, because we know the cosine, we know the spring force, then we can find from 1, we can solve for the normal force, which is the springs times cosine, and I have it right here. Let me write it anyway. 3 times 1.25 minus 0.75 times cosine, which is 0.75 over 1.25. So if we calculate all that, we get the normal force, which is 0.9 newtons. This is my first result. And from the equation 2, I have the spring force, the sine, the weight, and all I need to find is the tangent. So I will solve for AT, and that is spring force, sine, which is this one, 1 over 1.25, right? Minus weight, 2 kilograms, so it is 2 times 9.81, and all divided by 2. I will put that negative 2 here, so negative 2. So at the end, when we solve, we get that the tangent acceleration is 9.21 meters over second square. And those are the two values, acceleration and normal force, that we were asked to find.